Hello friends, welcome to Ansys-Tutor. In this video, we are going to design and simulate a reverse sediment sampler for isokinetic conditions using ANSYS Fluent. There are two samplers placed parallel to each other. The sampler's diameter is 98 mm and it is 1000 mm length. The samplers are aligned with the flow directions. The river flow velocity is said to be 1 meter per second. Our objective is to analyze the internal flow behavior to assess whether the design achieves isokinetic sampling conditions. The study is conducted using ANSYS Fluent. So let's start. Drag the fluid flow fluent into project schematic. Select the geometry and change the analysis type to 2D. Then right click on geometry and select new design modeler geometry. Go to units, change it to millimeter. Now go to XY plane. We are going to draw the geometry in the XY plane. For this, go to sketching. Select the rectangle option and draw a rectangle with the axis at the middle. Now go to dimensions and put the dimensions of this rectangle. Now go to constraints, select symmetry constant, select the axis first, then the two sides of this rectangle. Now put the values 1000 mm, width is 98 mm. Now again go to draw toolbar and select the polyline option and draw the front part of this sampler. Right click and select open end. Now again go to dimensions and put the dimensions of this diffuser part. Then go to symmetry, select the axis and select the two sides of this diffuser. Now put the dimensions. Our inlet is 4 mm, inlet die is 4 mm, length is 350 mm. Now we are going to trim out these lines of this rectangle and click on generate. Now we are going to split this outlet section. Split it this line for the outlet section. Now again putting the dimensions. The outlet is also 4 mm. Now go to constraints and impose same length on the top and bottom lines of this outlet, so that the outlet would be at the middle section. Then click on generate. Now we are going to offset these lines to create the body of this pipe, body of this sampler. For this, go to offset tool, select all these lines of this sketch, Hold the control key and select all these lines as well as the vertex points. Now click on the offset. Now click anywhere on the screen to place this offset. We will provide the offset distance later on. Now offset is placed. Right click and click on end. Now we are going to provide this offset distance of this offset lines. For this, go to dimensions, select the vertical dimensions and put the dimensions for the offset lines. Keep it as 2 mm. Now we are going to draw two lines at the inlet to create the inlet and the outlets. Select the polyline option and draw the inlet section and outlet sections. Now go to modify and trim out the sections to create the outlet and inlet sections. Trim out these lines to create the outlet. Similarly, trim out the lines at the inlet. Now this sketch is complete. We are now going to convert this 2D sketch to a 2D surface. For this, go to concept tab and select surface from sketches. Select any one line of this sketch, then click on apply and click on generate. You can see there are two surface body has been generated. One is the top half of this pipe and second is the bottom half. As these are disconnected, so two surface body has been generated. Now we are going to translate this two surface body. For this, go to create and select translate. Select the preserve tool bodies as yes. Select the two surface bodies. Hold the control key and select two surface bodies. Then click on apply. Now select the direction where you want to put the copy. We want to place this second copy at the top Y surface, the top Y axis, a distance of 600 mm. Then click on generate. You can see another copy has been generated. Two samplers has been prepared. Now we are going to create the outer boundary, outer surface, outer rectangle for the river geometry. Add another sketch. Draw a rectangle. Now put the dimensions of this rectangle to create the outer boundary geometry of this around these samplers. Put the vertical and horizontal dimensions. Now we are now going to convert this outer rectangle to a 2D surface. Go to concept tab and select surface from sketches. Select the outer sketch, rectangle sketch, and then click on apply. Keep it as add frozen or add material, then click on generate. You can see 2D surface has been generated. Now go to booleans, select the subtract option, select the boundary as the target body and the 4 surfaces as the tool body. Then click on apply. Reserve tool body option as no, then click on generate. Now you can see there is creation of this void spaces in this fluid domain body. This is the creation of our sampler geometry. Now we are going to split this fluid domain so that it would be better for us to mesh. So we are going to draw. We are going to insert another sketch and we are going to draw various lines around these two samplers. We are going to split these surfaces so that there would be a better structured mesh around these two samplers. Split it like this as shown in this. Now put the dimensions. Put the dimensions of this lines from the axis. Now we are going to convert these sketches into line body. Now select lines from sketches option. Select all the sketches and click on apply. The line body has been formed. We will go to tools menu and select projection option. Select the line bodies. Select the edges of this line bodies. Hold control key and select all these edges of this line body. Then click on apply. Now select this surface as the target and click on generate. Now you can see the surface has been splitted. This splitting will be helpful for us during the meshing. suppress the line body, it is not required. Geometry is complete. Close this geometry and proceed for meshing. Open the meshing workbench. Now insert the edge sizing. Select these edges, all these parallel edges. Select the number of divisions option and put the number of divisions up to 300. Insert another edge sizing for the middle parallel lines. Select all these, right click and select insert edge sizing. Now select number of divisions options and put the divisions up to 200. Similarly, another edge sizing, right click and select sizing option. Select the type as number of divisions and put number of divisions up to 100. Insert these vertical lines, edge sizing for these vertical lines. Put the number of divisions up to 50. Similarly, insert another edge sizing for the bottom vertical lines and put the number of divisions up to 40. Insert another edge sizing for the middle vertical lines and put the number of divisions up to 30. Now the important section is this part in which the sampler has been placed. We are going to provide maximum number of divisions over here so that maximum cells should capture the solutions. We put the divisions up to 20. Insert face meshing to all these faces except this middle two. Right click on the mesh and select generate mesh. You can see the mesh has been generated. We are going to increase the number of cells in this inside this sampler, so it would capture these results properly. Would insert and select sizing. We are going to provide the edge sizings to these edges of this sampler. You need to zoom in so that these edges would be selected. These are very small. Now put number of divisions up to 300. Go to insert and select sizing for the diffuser parts also. Select the edges. Both for the top and bottom samplers. So all these 4 edges should be selected. Then click on apply. I put the number of divisions option and enter the number of divisions up to 100. Now again going to remesh this geometry. Click on generate mesh. There is the adaptive sizing option. Turn on the adaptive sizing option and then generate the mesh. You can see the inside of this sampler geometry has been meshed with some smaller cells. We are going to increase the number of divisions at this edges. So the cells should be smaller in these sections also. This edge sizing at this outer section and again remeshing it. We are going to increase number of divisions at this middle sections, increase up to 50 and change the behavior up to hard. And click on generate mesh again. Now select this, all these lines of this let part and create a name selection as inlet. Similarly, select all these lines of this outlet part and name it as outlet. Hold the control key and select all these edges. Right click and select create name selection. Name it as outlet. Select the top and bottom part of this outer rectangle, bottom lines of this outer rectangle and name it as symmetry. Now select all these edges of these samplers. Select all these edges of this tour sampler. You need to be zoomed in to select all these edges. Similarly, select all these lines of this bottom sampler. Right click and create name selection. Name it as wall, pipe wall. Name selection has been complete. Now update this mesh. And proceed for solver setup in Fluent. Close this meshing workbench. Open the setup. Select the double precision model. Then click on start. Now go to models. Keep the default viscous, turbulent viscous model. K omega, SST K omega model. then click on OK. Now go to materials menu. Open the Fluent database, add the water liquid, select copy, then close, select change create, then close. Now go to cell zone conditions, assign the water to the fluid domain body. The default material has been selected as air, change it to water. Then click on apply, then close. Now go to boundary conditions, select the inlet, click on edit, put the inlet velocity as 1 meter per second, click on apply, then close. Keep all the default boundary conditions for all these walls. Symmetry wall boundary condition has been provided so that there would be no complex calculations near the walls of this outer rectangle. Go to methods and select green gauge cell based method for better accuracy. Go to monitors, select residuals, decrease the residuals up to 10 to the power minus 6 for better accuracy. Then click on OK. Now go to initialization. Select the hybrid initialization and click on initialize. Hybrid initialization has been started. Initialization is complete. Go to run calculation page. Enter the number of iteration as 1000. Then click on calculate. Now the iteration process has been started. It will take some time. The calculation is complete. It has been converged at 195 iterations. We can now close this Fluent solver and proceed for CFD post processing to see the results. Open the results window. Insert a new contour. Select the location as the surface symmetry 1. Select the variable as velocity. Enter the number of contours as 100. Then click on apply. This is the velocity variations around these two samplers. You can save this image of these samplers. Select the image quality. Set the image quality and click on save. The image would be saved at the result locations. Now we are going to insert a streamline to see how the fluid is entering into this sampler. Select the surface streamline option. Enter the number of points as 500 and click on apply. The fluid path along these samplers, as the fluid passage entrance is very small, so small amount of fluid is entering, small amount of water is entering into this sampler. You can save this image for further use. With this, let's conclude this demonstration. If you have any doubt, then please ask. Subscribe to our channel if you are new to our channel. Thank you. Keep learning and keep exploring.